Good morning, boys and girls. I hope you're having a great week. Right now, I am currently in Iceland, having a great time. So I didn't want to lose this whole week of instruction without me being here. So I'm going to do the best that I can to walk you through surface area and volume. Volume is pretty easy. A lot of students don't have too much trouble with this. Surface area can be tricky because we're holding a lot of different numbers, all right? While you're watching this video, you're going to fill out these notes. So follow along, fill in any blanks that you see as Mr. Costal is kind of breaking volume and surface area down. Once you're done, you can color this, and then there's two problems that go along, and there's also some practice on the back as well, okay? So, when we are talking about volume, we're thinking, all right, we have a three-dimensional object. Volume is how much can we fit inside of that. So we know that Mr. Costal loves Expo markers, all right? And when we take a look at this Expo marker box, we can measure the different sides and find out how many inches, squared inches, would fit inside of that, all right? So the formula for volume is just my width times my base times my height, all right? So what I would do is I've made this Expo marker box a net, and a net is what's going to help us with surface area. But I've got my measurements here, and when we take a look right here on the side of the Expo box, we know that it's 3 inches long and 2 inches high. So we have two of our measurements here. We have 3 times 2. And now when we look 3 times 2, we also need one more measurement, and that's going to be right along here, okay? So once again, I've just taken this three-dimensional image and I've made it a net. And a net is 2D, while this is 3D. So when we talk about volume, we're looking at 3D, surface area, and a net is going to be two-dimensional, right? So the last number that I have here is 4 3/4. Boys and girls, you don't have to get too concerned with which one of these comes first because of the commutative property of multiplication. I can mix these around, right? So if you misidentify the width or the height, it's okay, all right? What I'm going to do here to find how many cubic inches fit inside, I'm just going to multiply these across. And we have 6, and then 6 times 4 3/4. I'm going to grab I'll do this multiplication, so 6 over 1. When we multiply, we can't have mixed numbers, so I change this to improper. 4 times 4 is 16. 16 plus 3 is 19. Fourths, I can simplify here. 2 goes into each of those. And now I have 2, and 19 times 3 is 57. 2 goes into 57 28 times, and then 2 times 28 is 56, so I would have 1/2 left over. 28 and a half inches, that's my unit of measure. I could have measured this in centimeters, meters, whatever. I decided to measure in inches. 28 and a half inches cubed. Now, this is very important that we cube this because we're talking about three-dimensional, how much fits inside. So when we look inside, how much can we fit on every single dimension, all right? So volume, width times base times height, doesn't matter what order you put them in, and we're looking for this inches cubed, all right? Now, surface area. A lot of students have a hard time with surface area. I'm not going to show you a specific formula for surface area. What I want you to think of instead is when I take this box, surface area, instead of looking at how much I'm going to put inside, it's how much wrapping paper would go around it, okay? So we're not really looking at three-dimensional because we're actually breaking this down into a 2D image. Sometimes we have to do this in our mind, right? If we have a test and it has the picture, we can't actually unfold this box, all right? So we have to do it mentally. Now, when I'm looking at surface area, let's look at this side of the box, and we'll pretend that this is the front, okay? So when I look at the front of the box, I'm I'm just going to find the area for this one side. Boys and girls, surface area is a lot of work. It's a lot of numbers, and that's why we usually get mistakes, because students either don't want to or just make a mistake on holding all these numbers together, right? So I'm just looking at this face, just this face right here. I've made a net, taken it from 3D to 2D. Now, if this side length, which is the back of the box, is 4 3/4, then this side length also has to be 4 3/4 inches. Why? Because it's a rectangular prism. So 4 3/4 is the length of this. Well, it's got to be the length of that, and so on. Okay? So just looking at the front of the box, to find the surface area, because it's a rectangular prism, I'm just going to do 4 3/4 times 3, because that's my height, right? So base times my height, which we already learned. Now, just to make this calculation a little bit quicker, Mr. Costello is going to do this with a calculator, which you can use as well in this activity. So we have 4 3/4 times 3. And that's going to be 14.25 inches squared. Why squared? Because we've made this two-dimensional. It's no longer three-dimensional, okay? All right, so if I have a front, then I also have a back. So here's my front, here's my back. They are the same exact measurement. So I could do this, I could just copy it, and that equals 14.25 inches squared. All right? How many sides do I have? I have a front, I have a back, I have a bottom, I have a top, side, and side. So I have 1, 2, 3, 4, 5, 6. How many different areas should I have? I should have 6, and then I'm going to add them all together, all right? Right now, I've only done the front and the back using my net. All right, so now let's do the top and the bottom. So right here is the top, and this side length is 2 inches. We've already determined if this side right here is 4 3/4 inches, then this side has to be 4 3/4 inches. So we have 4 3/4 times 2, and I'm looking at this side right here, just that side. All right, and once again, I'm going to use the calculator. Actually this whole week's activities, all of them, you can use it as well. 4 3/4 times 2, that's going to give me 9.5. Once again, inches squared. Just like I have a top, I have a bottom, and that bottom is going to be the same. The bottom is represented right here. Here's the base, here's the height. They're the same, so I'm going to multiply those. All right. Last but certainly not least, this is the front, this is the back, this is the top, this is the bottom. I still have to do the sides. Once again, I'm wrapping this with wrapping paper. I want to give somebody a box of Expos. How many inches total does the outside take up? So the side is 2, base of 2, height of 3, which equals 6 inches squared. This side is the same as this side, right? I unfolded it, I made a net. 2 times 3 also equals 6 inches squared. Now I've got these 6 different numbers. I need to add them all together in order to get the total surface area here. 6 times 6 is 12. A half plus a half is 1, so I'm at 13. 13 plus 18, we'll just double check my calculations, right? 9.5 times 2 plus 12. So 9.5, 9.5, 6, and 6 equal 31. And I need to add these as well. Just adding them all together. Plus 14.25 plus 14.25. We get a total surface area of 59.5 inches squared. Why squared? Once again, we broke this up into a net It's two-dimensional. We're looking at the outside, not how much can fit in the inside. All right, today, what you're going to do is you're going to get a paper that looks like this. All right? You are going to measure all of the different sides. These right here are just so you can fold and make a three-dimensional shape. So these pieces right here, you're not necessarily going to measure. You want to be looking at all the straight lines. So this, right? These here are so you can tape it or glue it and make your three-dimensional shape. So you want to do all your measurements. You want to find the area of each different shape. So the area of this, add them together. The area of this, add it. Area, and you're looking at a three-dimensional shape that we're making 2D, making a net. This is your net, and then we'll fold it all together and make three-dimensional. Mr. Costel's done one for you. So I have this 2D net. I'm going to find the area of this, and this. I'm going to add them all together. That will give me the surface area. That's different than the volume. The volume, I would just multiply the base times the height, and then I would multiply the width, and that would give me how many units cubed can fit inside. All right? This substitute will give you some more clarification on this. I hope this video helps, and have a great week, and I look forward to seeing you after the Super Bowl when the Birds are the champs.